Now, we are in Module 9 in the mathematics course. So, Module 9 introduces statistics as a structured discipline for collecting, tabulating, and presenting data so patterns become clear and decisions are informed. So, this module will cover frequency distribution, graphical displays, and measures of central tendency and spread. It will emphasize conceptual understanding as well as computational accuracy. So, in this module, expect to practice how to classify data, how to construct tables, how to interpret graphs, how to compute mean, median, mode, range, variance, and standard deviation, and also the application of statistics to different fields of life. So, what is even statistics? Statistics uses scientific method. It's just a scientific method of collecting, organizing, summarizing, presenting, analyzing, and even interpreting data so raw numbers become meaningful information for decision making. So that is statistics. Just a method for collecting, organizing, summarizing, analyzing, and interpreting data so that data is properly converted to meaningful information. So there are two principal methods of presenting data. We can present data in tabular form, and we can also present data in graphical form. In tabular form, that includes presenting data in frequency tables, while in graphical method, this one is when you visualize data, making use of bar charts, pie charts, histograms, polygons, cumulative curve, etc. So both of them transform complex data set into accessible insights for research, for education, for planning, and even for business. Now, what is even the difference between data and information? Data are raw facts, numbers, words, or measurements collected about people, objects, or events. Data alone are often very unclear. But when you have information is simply data that have been processed, organized, and interpreted to answer questions or reveal patterns. For example, if you have individual test scores, that is the data. The class average, high-low scores, and the distribution that describe overall performance are information that supports the decision. So, raw score can be individual values such as age, scores, height, that are recorded as collected. But when they are processed, it become like in form of organized summaries, where you've calculated the mean, you find the median, the frequency table, and even try to visualize it using charts, so that it explains trends to support your decision. So data can also be classified into grouped and ungrouped data. Ungrouped data simply lists individual observations exactly as collected and this works well for when you have a small data set because every value remains visible. But in group data combine observations into class intervals or ranges, and is more applicable when you have large data sets. It reduces complexity and highlights overall patterns, although some details may be lost. Grouping prepares data, for frequency tables, histogram, and easier interpretation. We have generally two types of data. We have quantitative data and qualitative data. Quantitative data is a form of numerical measurements that answer questions such as how many or how much, and is usable in calculations. So it includes discrete and continuous data. When we say discrete data, I'm referring to either counts, whole numbers. Continuous data can be measurements that can be fractional, like height, weight, or time. Not of qualitative data. This is a form of descriptive data. It emphasizes description of quality. It talks about color, brand, and gender, for instance, and it helps to classify attributes. Sometimes it is coded numerically for storage, but codes are not quantities and cannot be used in arithmetic operations. Now, this is how a frequency table looks like. In a frequency table, you will see a number of observations, or the observations, the tally, and the frequency. Frequency table summarizes how often values or categories appear or occur, and it makes large data set manageable and forming the basis for graphs. The key components of a frequency table include variable column, tally column for counting, although is optional, and a frequency column that determines the number of counts, where you write down the number of counts. So frequency table reveals patterns quickly and supports bar chart, histogram, and pie charts. Now let's talk about measures of central tendency. When you hear measures of central tendency, what we mean is mean, median, and mode. Mean is the arithmetic average, median is simply the middle number, and the mode is the number that appears most. So how do you calculate your arithmetic average? You do that by summing up the values and dividing by the count. Okay. Then for the median, the middle value is, I said, is the middle value when observations are ordered. So if you order your observations, the middle value is the median. But when you have even counts, median is always the average of the two middle values. Okay. Then for mode, say mode refers to the most frequent value or observation, and this is useful for identifying common or popular outcomes. Distributions may be unimodal, bimodal, or multimodal. Let's look at measures of spread. In measures of spread, or measures of dispersion, we are talking about range, variance, standard deviation, and mean deviation. Measure of spread quantifies how values differ from the center. For instance, range is equal to maximum minus minimum value. This is just a simple spread. Maybe you are given set of scores. If the highest value in the score is 10 and the lowest is 2, if you want to calculate the spread, you can just use a simple range to get a simple spread. It will just be 10 minus 2, and it will be 8. Okay. Then variance. Variance is average squared deviation from the mean, while standard deviation is the square root of variance. Mean deviation is average absolute deviation from the mean. So these measures help assess consistency. Okay, because small spread means consistent data, while large spread means high variability. So you will see different examples in the module. So when you look at it, you see step by step on how to solve them. Okay, let's talk about graphs and charts. Graphs and charts are important, but table is the precursor for charts. So when do you use bar chart, pie chart, or histogram? For instance, bar chart is best for qualitative or discrete data. Bars are separated by equal gaps, and height is proportional to frequency. So this is just for simple comparison across categories. But for pie chart just shows parts of a whole using sectoral angles proportional to frequency. So this is used when total composition matters and slices are few and distinct. Then for histogram, this is used for grouped continuous data. Bars touch to indicate continuous ranges, and it is useful for revealing distribution, shape, and density across intervals. So in plotting graphs, first you need to have your table. You know, you need to do some of the calculations. When you go to the module, the notes, you will see a lot about it. Okay, so what is even the importance of statistics? We need to know what is statistics used for. Now, statistics is applied in the real world of business. For instance, in business, it is used in manufacturing industry, in sports, in science, in agriculture, and even technology. They all rely on statistical summaries to predict, control quality, evaluate performance, guide policy, and even train algorithms, turning scattered records into actionable insight. So statistics is a coherent system for converting data into information. That is just it. The focus of statistics is to convert data into meaningful insights for decision making. And this can be done through collection of data, analysis of data, visualizing data, and that is what this module is all about. You can even apply statistics to your daily lives, your daily spending, your daily income, expenditure, and co. You can apply it. So it's applicable to every sphere of life. If your focus is to convert data into useful information, what you actually need is to apply statistics. Now, this is the end of the module. Thank you for listening.